yours for us, please. So first demonstrate. Yep, demonstrate it for us.
I get how it moves.
And tell us what we're hearing.
This is the lowest frequency.
Low frequency. Harder. They won't break. Higher frequency. Highest frequency. So what'd you write?
So I wrote that when you change the length of these, the frequency is affected. So making them longer makes the frequency decrease, and making them shorter makes the frequency increase. Because when the frequency is lower, the wavelength is longer, and vice versa.
An inverse relationship. Okay, and now she's going to make her resonator work. I'm going to ask you to do the short one. She's going to make the short one resonate. There she goes. Awesome. All right, so I'm going to stamp. So we see length is affecting our frequency. Inverse relationship. Remember that. Length is affecting the frequency. All right, Angela, you're on. So first show us. So tell us what you're doing and what we're hearing.
The blue marker, and then when I hit it, the cap on, it makes a deeper noise, and when I take the cap off, it has a higher frequency. So when I took the cap off, the frequency was increased, and then with the cap off, the frequency was higher, while with the cap on, it was lower.
And then why did you think that was?
I believe this happens because when the cap is on, the waves get trapped at this side, and then it keeps echoing the sound. Well, with the cap off, the waves just travel without being stopped.
So it gets a bigger distance to travel, right?
Yeah.
So again, we're seeing bigger, right? Lower frequency, smaller, higher frequency. Oh, and then your resonator. Make the middle one resonate. There we go. Takes a little practice, but she's got it. Awesome. All right, table 3. So first you're gonna show it to us and tell us what we're seing.
All right, so we got a motor on a string pretty much. Oh, it does. It creates 3 waves.
So you can see the standing wave, guys.
And
Can you make it a different? Can you make it different?
Oh yeah, you can change it just by holding somewhere else, and then you'll have a different amount of waves.
Okay. Can you
hold
do
down
one
low,
more?
You can get half a wave.
Right there. So he's trying to get to a node. Okay. And so then explain to us how it works.
It's just spinning.
No, I meant your frequency thing. What are you writing?
Oh, this. Oh, what I wrote. Oh, right. It doesn't
Yeah.
affect frequency. Because it says it's constant, and that the only thing you can change is the amount of waves you see.
You can only change the amount of waves because the frequency is constant because it's due to the motor spinning. All right. So let's look at their resonator. Let's try the long one. Look at the long one. Oh, that's the middle one. Long one. That's the middle one. He's really good at the middle one.
I can't do the middle one.
There we go. What did you have to do differently to get it to work that you were having? What are you changing to make it resonate?
Yeah, to slow down the
You gotta slow, not your speed, your
movement.
frequency, right? So I want to use the right word. So speed is how fast it's going, which is not what you have here. Yep. That's it. All right, table 4. Table 4 is quiet, so you gotta listen. Oh, she's gonna go put water in it. She doesn't have water in it yet. If you want to do it from there, so you can pour the water out too. You could bring it and then tell us. She's attempting to fill it with water. All right.
So it's the best amount of water. It depends on amount of water. So now it's full. So I'm trying. There is no sound. Less water.
So the frequency is getting higher.
So frequency higher.
Now frequency lower.
It's different.
Right? So what did you guys write on your board?
So I wrote, when we change the amount of water, the frequency increase or decrease both. So the higher amount of the mid frequency decrease and less amount of water it increase. So I think this is because of inverse relationship.
The inverse relationship. Nice. So again, we're seeing length and frequency, right? Length and frequency are giving us an inverse relationship. All right, who's doing the resonator? Is Kaylani doing it or are you doing it? Who's doing the pencil? All right, so let's see, do the short one. Make the short one resonate. Well, no, you can't hold the other two. There we go. That's pretty good. That's pretty good. All right. Stamp page. All right. Table 5. What did you guys do?
I actually don't remember what this is called.
I called it a wave spinner because I had no other idea what to call it.
The crinkle tube. The crinkle tube.
Corrugated tube. I don't know. Whatever you want to call
So
it.
we all do something.
Zips out.
You have to like.
Okay. Can you get a different frequency? There we go. All right. So what did you? You hear the frequency changing, right? As he goes faster. Nice. Thank you, David. All right. So what did you guys write?
When we change the speed or the velocity of the tube, the frequency increased.
And why is that?
Because crap. It's because it caused like a certain type of vibrations.
What's the wave equation? V equals lambda F. So V goes up,
And then lambda's like.
and lambda's constant because it's the length of your tube. So then
Frequency also goes
after,
up.
that's why I tried to have you do it shorter, but it wouldn't work, right? Because then you change lambda. But
It's also open like on the other side.
yeah, it's hard to do that. Oh, make your resonator work. But this one lambda was constant, but they could change the speed and frequency.
Wait, which
Okay, so let's do the long one. The long one. There you go. Nice resonation. Yay. What does resonation mean? When I say make it resonate, what does that mean? How do I know it's resonating? How do I know that he's being successful? What do I see with my eyes?
Strings.
Really big. What's the physics? What would be the wave word?
Undulation.
What was got big? But that's not the
Period.
No, not period.
When waves add together.
Starts with an A.
Amplitude.
Amplitude. It's gotta, the period's actually the same for each one of those. It's a pendulum, right? The period's all the same. It's just got a bigger amplitude. So that's what I'm looking for, is a really big amplitude. All right. So this group's going to demonstrate it without hitting anybody. I'm going to come over here so I don't get slammed in the head by a football. So hear the difference? Okay. He's not going to hit himself. And then explain what we heard.
So when the football is spinning further away from you, the frequency is lower, and when the football comes back towards you, the frequency is higher.
Mm-hmm.
This means that when the waves like collide, like are smushed together, the frequency is higher, and then it's a lower frequency when the waves are stretched out. That's why it's a lower.
That makes sense. So it's coming towards you, it gets squished together, so those little bumps get higher, right? So you hear a higher frequency. When it's moving away from you, it extends. That's called the Doppler effect. That's why it's the Doppler football. You've heard of Doppler, right? They let me know storms are coming towards you or away from you. So you just heard it. Oh, and then, all right, David's going to do it. I saw him do it before. Let's do the short one. Do the short one. Nice! Look at that. Awesome. All right, table 7. Add tuning forks.
Okay, so we have 2 tuning forks, and we found that the longer one, which is this one, has a lower pitch. So that means it's
Can you show us too so we can hear it?
Yeah, which means that its frequency is not as high as this one. So
Hear the higher pitch? Yeah. And then why did you decide that was?
because we know that there's an inverse. They're inversely proportionate when it's like the length versus frequency.
Nice. All right, and then who's going to do the resonator? All right, let's try doing the middle one. He's like, that's the worst one. I don't know. They're all about the same. James got this. Nice. Look at that. It didn't even take her very long. Very nice. All right. Last group, Sebastian. So his is on the table over there. He's trying to get a loud sound.
Yeah, it's not super loud.
Yeah, no, it's down.
It's
You
like
almost got
kind
it
of
down
noise.
lower.
Can you guys hear anything?
It's because your hand is like covering the board.
Try turning it sideways too. Yeah, like that. There. Oh, you keep going right by it. Go down.
Can anyone hear it?
Okay, and then now do it with the other one. Oh, there it is, right there. All right, so what did he write?
Okay, so when we changed the length of the tuning fork to be longer, it seemed like the frequency increased and the length, or no, it decreased and the length of the tube increased as the tuning fork's length increased. So we believe the tube affected the frequency and the tuning fork affected the length.
So is that an inverse relationship or a direct relationship?
Inverse.
Inverse. So again, we're seeing longer length, smaller frequency. Okay, can you do your resonator and let's see you do the short one. Make the shortest string resonate. Very nice. You guys make it look so easy. Alright, so this is what I want you to do. I want you to erase your boards, put your pens in eraser rags.